So, guys, is anyone. Guys, does anybody have any of these you'd like to show us? Anybody want to come up or you? Does anyone want to show the first one? Anybody got the first one down?
Yeah, I can show the first one. I'm down.
I gotta get bits and parts and stuff.
Yeah, let's do it.
Come on up here.
Why is it loud, girl?
Who's coming?
Shalom's doing it.
Oh, come here, Sheila.
Thanks, Grace. You're welcome.
Sheila.
Okay. Okay. Wait, here it is. Okay. Okay. So we start with one. Sorry. So this is 10 in base 4. So there's one of those. And then you have 3 ones here. So you're adding 2 more ones, which makes
Sorry.
which makes 21 in base 4.
Yeah, so I think everybody, all the groups I went by that asked about that problem, got it right. And it's now real quick, there's the computational aspect behind this stuff, right? So on the day of when I ask you to do manipulative problems, if you don't do the math at your desk before coming up, you don't make sense to me. So, like, how do you do the math of this? How do you change 13 base 4 into base 10? What are the places that it's in base 4, so it's in different places?
1, 4.
So 1, 4, and 3 ones is what number?
7.
That's insane. And then I want to add 2 to it. Of course, 2 base 4 is just 2.
Yeah.
And I get 9. So when you got 21, why does that jive with this? This is what you would do at your desk. So you know you're supposed to get 9. And what is 2 4s and 1 1? 9. You guys see what I'm saying? So if you work it out ahead of time, you know what you should get. You'll come up a little more confident to do the manipulatives. Okay. In the interest of time, I'll do the next few, and then I'll see if anybody wants to do any of the fraction ones. So I got 21 base 4, and I want to take away 3. What do I need to do? And you see this idea with the chips? I don't have enough ones to take 3 of them away. I don't have enough units to take 3 of them away. So I change this. Now can I take 3 away?
Yes.
Yes. And my answer is 12 base 4. Kick ass! By the way, are you guys cool with the fact that 12 base 4 plus 3 base 4 is the same thing as 13 base 4 plus 2 base 4? Let me say that again. Do y'all agree? 12 base 4 plus 3 base 4 is the same thing as 13 base 4 plus 2 base 4. Do you guys see that? Don't they both have 2 plus 3 with a 10? So this was 21, yes? And this is 21, so they all seem to be connected. I don't know if Jeff did that on purpose. He might have. You never know with this guy. Is everybody cool with part B? So the thing, it's not a direct correlation, but the chips, if I don't have enough, I got to give myself more. So how did we give ourselves more? We took one of these and broke it down. That gave me more units, so I could take 4 of them up, 3 of them more. Yes. Same kind of manipulative idea. This. Let's talk about manipulatives first. So I give myself 9 little bits. What is that? 7? 8, 9. And then, of course, I can lock those together. A really good thing to do with little ones is, and I actually have these. I always forget that I have these. The little block, remember the little blocks that click together? Oh, that's so satisfying. It's almost as good as the bubble wrap, yes?
Yeah.
Just the opposite. You click those together, the bubble wrap you destroy. So it's like, so I have 9, so each of these become a long, and then I end up with the magic 21 again. Okay. Is everybody cool? How do I do this computationally, well, what places are there in base 4? Now look, is this in base 4 already? So these are blank. And is 16, is that too far?
Yeah.
Good, always go 1 too far so you know you went far enough. 4 goes into 9 how many times? Twice, and I've taken care of 8, so of course they got 1 left. There's your magic 21, yes? So you can always do the math of it at your desk before you come up to the physical manipulations. Okay. 5/3 convert to a mixed number. Actually, let me ask this. Does anyone want to do any of these 3? Which one do you want to do?
I'll do the second.
Second one? Okay, come on. I've got bits and pieces here.
So first you have 1/2, and you're adding 2/3. So you take 2/3, and then you can put. I did it this way, where you take 1/2 and then you put the 2/3 like that, and you have this funky shape, and then take a hole. Put it like that, and it has like a little hat, and then it ends up like that. So then you have 1 and 1/6.
That kicks ass. All right. Sure, we do that. Did anybody do it a different way? Because that was kind of cool. That way is a way that you don't see too often. Did anybody do like, where to go? 1/2, 2/3, and then you can change these into 6ths. Someday I will do it. Come here. All right, bam. So that one goes away. That one goes away. And now when I add these, they will actually add. You can see how physically you can see the similarity between the way Lily did and the way I did it. It just depends on preference, right? So you get 1 and 1/6 either way you do it. Kick ass. And of course, you all can do this. How would I do this computationally? What do I need? Gamma nama nama. So the thing I just did is a little tiny bit better to show when you're about to show common denominators, because this 6, I needed it so I can make a full 1, which helps explain why the LCD is 6. Because I can break them all down into the triangle pieces, which are all 6ths. Yes? This would be 3, 6 plus
4, 6.
4, 6 is
7, 6.
7, 6, which is 6, 6 plus 1, 6, which is 1 and 1/6. Yay! All right, so let's see. 5/3 to a mixed number. Where am I? There. Oh my God, there's stuff. Where's? Oh, I have 2 there. There we go. So here's 5/3. So then this is literally just putting them together. 5/3 to mixed number is 1 and 2/3, yes. So it's just reorganizing the shapes that you're given. That's fascinating, Jeff.
Wow.
What's up?
That's a wow.
Wow, I like it. That's a good reaction. And then 2 and 1/6 minus 2/3. So I need to be able to take away 2/3 from this. So what's the thing I can do that's the same thing has happened once already and about to happen again? I don't have any thirds, so what do? What do I do? Take one of these bad boys. And now can I take away 2/3? Yes. And then what does this give me? Aha, 1.5. Yay! And again, if I want to do this by, is everybody cool with that?
Yeah.
If I want to do this by hand, what would I have to do? There's a few different answers you can give me. One of much more standard. Yeah, comment in no. Now, real quick, is there a problem with that? Isn't 4 6 bigger than 1 6?
Yeah.
Yeah, so you could just do what?
2 times 2 plus 1.
Yeah, 13 6 minus 4 6 is
9 6.
9 6, which is
1 and 3 6.
yeah 3. Careful. 3 halves, which is 1 1/2, which is what we got. Yes. Or what'd you say? I'm sorry, you said 1 and 3
Well, I
6.
said 1 and 3 6.
You're good,
Then it
and then-
simplifies
alright.
to 1 and 1.
Yeah. Is everybody, you guys cool with that? The other way to do this real quick is, and this is the weird way to do this. This is 2 and negative 3 6, which is 2 minus 1/2, which is 1 1/2. That still works. But that's definitely a weird way to do it. Don't look at that. Okay, how these go? Anybody want to do any of these 3? Anybody? Yes? Which one are you going to do?
Oh, whichever one.
You do one? The first one?
Oh, whichever one you want. This one.
I want you to do the last one.
Oh, dang it. I was hoping you wouldn't say that.
You set yourself up for that.
Oh,
You can ask for help in the crowd if you need it.
Wait. Do I have to explain it or can I just do it?
Well, see,
Says the future teacher.
I wasn't gonna say anything. Yeah, I was gonna say, well,
Okay.
you might have to talk a little bit.
Okay, so my understanding is you're taking away 2 groups of 3 or 3 groups of 2?
What do you guys think?
3 groups of 2.
3 groups of 2.
So it'd be like this. 3 groups, 1, 2, and then you're, what's it called when you, oh my god, that's so cool.
So now
what-
tell us exactly why you're doing what you're doing.
This is when you're like adding this 0,
Good?
that's what it is?
Sure,
Okay.
yes. So you've got a blank sheet of paper. Keep going.
Yeah. Okay, you have a blank slate, and then this is your first group.
Then be careful. What do we say? How many groups of what? If it, real quick, Jenna, if the problem, real quick, go with me. If the problem would have been 2 times negative 3,
Uh-huh.
what would you have put down on the paper?
2
How many groups of what? 2 times negative 3.
groups of negative 3.
2 groups of negative 3.
Here I
First
have-
number is the groups,
and then
and the second number is the of what,
Yeah.
yeah. So I want you to take away 3 groups of 2.
And then you have, wait, 3
I want you to take away 3
3
groups of 2. There we go, there we go.
Oh my goodness,
You're good, you're good.
can you guys see that?
You gotta be careful, yeah. I'm zoomed in a little much, but you can get there. By the way, those nails are nifty.
Your nails are so cute.
Really? Thank you guys. I did them myself.
Alright,
Okay, and then, wait, this is, what's the question here? You take this.
yeah, that's 3 groups of 2, and you're left with
Negative 6.
-6. Kick ass.
That is so stressful.
That is a very trippy idea that if I'm taking stuff away and I don't have enough of it, I've got to give myself enough until I can do it. And the only thing I'm allowed to give myself to not change the problem is 0. Okay. And of course, you could do that at your desk. We know mathematically there's no difference between A and B. This is one reason why I want to do part C, Janelle, is because these two are kind of connected. Come back to me. And because C was a harder one, so I just wanted to. Come back. Whenever I am adding, like in part A, it's automatically easier. Because so what do I start with?
You started with +2.
Start with +2. And then I want to unzoom a bit. And then I want to add to this picture what? -3. So whenever I'm adding, oh my God. Okay. Today's lesson brought to you by Optometrist over there. So whenever I'm adding stuff, it kicks so much ass. And then of course these both kill each other, so I get -1. This one Mathematically, it's the same damn thing, but when you're first teaching kids, you want to connect with them physically. That didn't come out right. You want them to do the physical idea. Well, I had some interesting comment back there. You want to get them to connect to the idea physically. There it is. So 2 minus 3 is literally taking away 3, which is why mathematicians of old had trouble with this. They didn't believe this was a real thing. They didn't accept this, and now we do this all the time. My bank does it all the time. So I got 2, and I'm supposed to take 3 away from that. So what do I do? So what I could do is just add 1 0, because now can I take 3 away? Yes. I could also add 3 zeros. Well, this is overkill, but you can add 3 zeros, and then I can take 3 away, and then these two kill each other, and then finally get to a -1. Yes. Now, of course, I keep saying parents have so much issue with this. They just don't. They understandably don't get this because they don't think about math on a physical level anymore. But it's really good for you guys. It's really good for everybody to see how math, I don't care what level of math, is related to physical reality. It's so cool to see. Anyway, okay. So any questions on that kind of stuff? Okay. So does everybody feel semi-comfortable with the manipulatives?
Yeah.
Because some of these we haven't used in a little while, so I wanted to carve some time out, especially these guys, right? Okay. All right, so now you can return to your desk if you like. Maybe can you pile up your stuff? Make it easy for me. Uh-oh. Done it in a very interesting way. No! Wait, wait.
Should I grab them? Thank you. Okay, I was like, canceled, all done.
Yeah, this should be mostly longs, mostly flats. Some cubic dudes. I will. We're gonna, well, now it's open to whatever you guys want to look at. All right. It takes a village. I like it. So guys, oh yeah, I forgot about that. Oh, sweet. One thing we definitely need to do is this one. I didn't put this on the key because I didn't give myself enough room. Yes?
Is this what the final is gonna look like?
I don't
You're
know.
like stressing us out so much.
No, I'm sorry. Listen. For example, real quick, number 4. Number 4, right? Number 4. You guys know it's going to be on the, you know it's going
You're
to
not
be,
gonna give
yes.
us the key at the bottom like you did at the beginning.
No,
right?
everything I've given you in the past, I will still give you.
Oh, okay.
I'm not going to suddenly go, and now you must memorize all of the Egypt. No. That is so evil. If you have happen to have memorized Egyptian numerals, that's neat. You can show off next time you're at the Natural History Museum. So on this tablet, they say 3 right there. If you haven't been to like the museum and look at the Egyptian stuff, it's really cool when you're like, oh, I know that number. Holy shit. There, sorry. So you know I'm gonna give you a problem like number 6 and 7. Yes, you guys with me? What's happening? I'm sorry. Huh? Oh shit. I said it, and I'm so happy I didn't mean it. It's so stupid. It's funny. You watch old people and we're like, what the hell? And I tell them, remember when we were that age, we had the same kind of stupid shit that meant nothing?
Yeah, what was your guys' number?
I will say our stupid shit was not quite as stupid. No, I'm joking. 6, 7. What the no, it's hard to compare, you know. Alright.
There's no.
It's stupid, no. So, what is going to be on the test? Yes, you know there's going to be divisibility rules. You know there's going to be. I can't. I'm not saying that the kind of problems I'm going to give you are going to be like these problems. But the ideas on this, yes? Now, am I going to put every idea that's on here on the final? No, there ain't enough time for that. So exactly which ideas am I not going to put on the final exam? We will find out Thursday. Yes, the sooner, if you just figured it out today, then you have to think backwards. It makes more sense. It's like at the end of 6th sense, you're like, oh, he's evil. The whole semester makes sense. Okay. So, anything you want to focus on? 16. Oh yeah. There's a few different ways to do this.
Sorry, what number did you say?
16. The one about Mrs. Keebler. What's up? Yeah, of course. Yeah, come on up.
Oh,
Get up here.
but you're gonna bring. That was my mom's name.
Everybody else has one, yes?
Thank you.
You're welcome. So guys, anybody try out number 16? Anybody else try out number 16?
Hold on.
Does anyone think they figured out number 16? So, maybe?
That's why I'm asking if I got it right or not.
Oh, okay.
Or if I, like, the process was right.
Guys, recipe for cookies makes enough for 3/5 of Miss Keebler's class of 45 students. Right there, can you figure out how many cookies the damn thing makes?
Roughly.
Right there, you can figure out how many cookies a recipe makes, yes? 27. 3/5 of 45, 5 goes into 45 9 times.
Yep.
9 times 3. So the recipe as it is makes 27 cookies. So if she makes 2 batches, how many cookies? No? If she makes 2 batches, how many cookies? 54.
Yeah.
So how many kids could get more than one? Could get 2 cookies? 9. Yes, assuming they all eat one, I should say. But. What's up? Yes. There's something about, are you a 1 slicer or a 2 slicer? If you have pizza and you're the first one to take, how many slices do you take? It's kind of like a personality test. 2 slices is not too bad. The whole damn thing is too bad for everybody else. Is that okay for 16? I mean, you could make a proportion, but there's really no reason. I got enough information to work it out just straight. Yes?
Can you do a numberalized demonstrator fraction? I know.
Number 15? This one? Okay. Does anyone know how to do number 15? Number 15.
Do you cut like make a line 0
Yeah, can you represent sevenths on a number line? How would you do that? Yeah, you go from 0 to 1, and you just make. I would actually put 0 and then go 1, 2, 3, 4, 5, 6, 7. What's the seventh line I draw? 1. Because that would be 7 sevenths. Yes? How do you do subtraction of a? I'm sorry, go ahead.
Well, I think I did this right, but I really wasn't sure because it seemed like too easy.
Yes, this is remarkably easy.
Oh, okay. Because I did what you did, so I like started at 1 7th and then ended at 7 sevenths,
Sure.
and then I like started at 6 sevenths,
Yes.
and then just went back.
Bam,
to
bam,
and
yes.
ended at 3 sevenths.
Yes,
Oh.
that's it. So it lined up 4 sevenths, sorry.
Starting at
6
I
sevenths.
just put down 5 sevenths. Okay.
Oh, okay, okay.
So
Uh,
yeah, 4 sevenths.
are you guys? So yes, this problem is easy. But I'm testing to make sure. It's not easy if you don't know how to make sevenths, right? It's not easy if you forgot how to even do a number line to demonstrate anything, yes? But, so if you remember how to do, like if I want to do 5 minus 3, I would just start it, I just go 1, 2, 3, 4, 5, start here and go 1, 2, 3, and then I'm at 2, yay, okay. So this one is just, you've got to break the number line up in such a way that you can represent all the sevenths. So then you literally just go, here's 0, 1, 2, 3, 4, 5, 6, 7. This is 1 because that's 7 sevenths. Then you find 6 sevenths, and you go back 2. So this is 1 7th, 2 7, 3, 4. So when you go back 2, you end up at 4 sevenths. Good Lord, Jeff, that's really awesome writing. Okay. Is that okay? So again, it's there's a lot of little parts to that you have to remember to set it up.
Can you walk through 18?
Oh, I sold a car at a profit of $500, and that $500 was 12% of the selling price. So 500 is 12% of X. So you can make an equation, yes? 500 equals, what's 12%? That's it. 0.12 times X. And then just divide by 0.12. So on the quiz, a lot of you guys made way too much of the percentage problem because the example I did was a harder one, and the one that was on the quiz was much more straightforward. This one is more straightforward than the problem we did together last time. Is that okay for you? I mean, I've got the answer you did, so is that okay for 18? What about 19? 19 to me is a much more interesting question. Now, you know, if I had put this on the final, I would have said explain or something. You have to be able to show me why. Because you got a 50-50 shot if you don't even know what the hell it's talking about. You just go, oh, yes. Then you would be wrong. It's too bad. So on the surface of this, it doesn't make any sense. If A is 20% less than B, which means A is smaller than B. In fact, to get to A, you subtract 20% of B away from B. You guys with me? There's no way in hell B could be 20% more than A, because that would mean to get to B, you take 20% of A and add it to A. That doesn't make any sense. 20% of A is less than 20% of B, because A is less than B. Now, how do you show this? Right? Now, you could explain everything I just explained. That's one way to do this, is not do any math and explain. Yes? But what would the math look like? I don't know. Oh, yeah. A is 20% less than B. That's what that looks like. A is 20% less than B. What's a whole B take away 0.2B? 0.8B. So A is 0.8B. In order for this to be true, B would have to be A plus 0.2A. So B would have to be 1.2A. Oh my God, Jeff. So real quick, if I take 20% off of something, here's a beautiful thing. If I take 20% off of something, how much of the price is left? What percentage is left? 80%. Yes. If I take 20% of the cookies, 80% of them are left, right? So if A is 20% less than B, it makes sense that A is 80% of B. If B is supposed to be 20% more than A, then B better be 1.2, 100 plus 20%, 120% of A. But that's not true. How do I solve this equation for B? How do I solve this for B? How do I get B by itself? Why is B not by itself? Yeah, divide by 0.8. Now what is 1 divided by 0.8? 1 divided by 0.8. You can do it in your calculator if you want to. 1.25. That is not 20% more, it's 25% more. So if A is 20% less than B, there's no way in hell that B is 20% more than A. Because a percentage, 20% does not equal 20%. 20% of B is more than 20% of A, because A is smaller than B. Bless you. Okay, I'm gonna stop. The more I say, the more confusing it's gonna get. But at a base level, you should know if you decrease my pay by 10% and then increase my pay by 10%, I don't get back to where I was. Because the first 10% was of a bigger number. So when I take 10% up, it's of a smaller number, I'm not gonna get back to the same place. That is fundamentally what this problem is saying. And you don't have to do the math. You can just say, well, no, Jeff, because 20% of B is gonna be more than 20% of A. You can't go back, or however you wanna say it. You don't have to do the math. Okay. We'll let go of that. Any other one you wanna look at?
What were 3 on the front?
Anyone except that one. No, I'm joking. 3. Oh, okay, yeah, okay. So, what does this symbol here mean? Or. I always like to think about like an exasperated parents, like, you, why don't you clean this room up? Or, yes? Somebody, clean the damn room up. Okay. Or is the nice bouncer. It says, in order to get into the answer, you have to be in A or in B. As long as, is 5 gonna be in the answer? Is 5 in set A or set B? Yes. So isn't the answer going to be bigger than either A or B alone? Because everybody that's in A has to be in there. That's what I normally do when I have a union question, a or question. I do one entire set. I would write 1A, 3, 5, C. Then I go, what have I not written yet that's in B? 6. 9. B. Yes. So my answer has to have every element that's in either one of those sets. So this would be 1A, 3, 5C, 6, 9B. Now, along the way, we answered part B. A and B is what is in both. To get into the answer, you must be in both. You have to be in A and B. What are the only things that are in both sets? 3 and C. That's the answer to part B. And is restrictive. It always makes things smaller. Or is allowable. It's, what's the opposite of restrictive? Inclusive. So it lets everybody in. Come on in, Neil. You just have to be in either one of those sets. Okay. Why did I have to give it that U set at the end? A, B, U. A, there's set A, yes.
Oh, everything.
There's set B, and there's set U. Which part of this could you not answer if I didn't tell you that universe? Part C, because what's part C asking you? What's not in set B? If I didn't give you the universe, you'd have to assume it's everything. Unless you would type, well, I'm not in there, and my car's not in there, and this guy named Fred's not in there. I mean, it'd be everything. I have to tell you what the universe is. So what is not in B is anything that's in the universe that's not in B. The universe is everything that could have been here. So not B is everything that could have been here that is not in there. So then you just list everything in the universe that's not. Yeah. Yeah, so let's list everything that's in the universe that's not in B. That's, because that just means not B. Yes?
I don't know if somebody already asked this, but on number 5, which is like page 82,
Yes, in the book.
or like, which part?
On page 82.
So, like, what there's like
A lot of page 82s?
like which chapter? Like, I don't know, just like.
No, just page, there's only one page 82.
Oh.
I love you guys. You're okay, you're okay. Page 82, number 5 is the, at some point in history, I have written in this book.
And then we're doing just all of this stuff, all of the.
Yeah, so converting from this to ours is a lot easier, would you agree? Put my hands on it. Sorry, Ben. I saw you over there like, oh! I'm like that jackass that messes up your food right before you take the picture.
Yeah, literally.
I like this Mayan numeral here.
3.
Do you guys remember the symbols in Mayan?
9 pancakes and bread.
Pancakes and blueberries. The blueberries were worth, and the pancakes were worth 5. What kind of sucks for that is, here, freeze. That's my book. What's this in Babylonian? 1, and what's this? 10. Okay. And of course, the Babylonians and the Mayans, as far as I know, they never met. They had no idea. Neither one of them could argue with the other one. Yes? I'm going to give you all the same stuff I gave you before, which were the Roman numerals, the Egyptian numerals, and the Mayan place value system. Yeah. Anybody remember what was weird about the Mayan place value system?
It's like base 60 or something.
It's almost base 20.
20, but the third place
It's
is
1s,
5,
20s, 360s, yes? Bless you. And they did that because they were agriculturally based, like most ancient civilizations were, and 360 was important because that's almost the only thing is our guess. It's our guess. It's our guess.
Could you go over? Well.
Guess. Oh.
No.
So prime factorization means what?
Oh, these 5 numbers after trying.
Yep. Take each one of these and make a factor tree. Go. Oh wait. If you haven't done this problem yet,
Oh, wait.
I'm here for you, right here. Not doing anything.
This is your thing.
Oh wow.
Oh, I messed up. This isn't mine. And I used the wrong pen. So that's it?
Yeah.
Alright, so
No, I don't.
45 is 9 times 5, which is 3 times 3 times 5. Is that cool? Too bad. 120 is 12 times 10, for example, right? Which is 2 times 2 times 2 times 3 times 5. Now again, I'm doing it in a little bit of room I've got, but you guys can be more explanatory. 12 is 4 times 3, which is 2 times 2 times 3 times 2 times 5 is 3 2s, 1 3, 1 5. Now, LCM means the smallest number you can multiply each of these up to be. And the days go by. Sorry.
Yeah.
Alright, so I can make the number of 3's match if I gave this guy one more 3, yes? So at what level of 3 do they match? How many 3's? 2. So if the whole idea at LCM is I want to multiply each number so they both become the same number. And I want to do that in a way where it's the smallest possible answer for that. Because I can just multiply 45 times 120. And that would be a common multiple, yes? You with me? Multiply 45 by 120, multiply 120 by 45, they're the same damn thing. But that's big. I want the smallest way to do that. So what I do is, I end up taking the smallest power, say this again, the biggest power on each factorization, on each thing. So like, what's the biggest power on my 3 between these two? The 2. And that relates to, if I gave him one more 3, that part would match. They already both have a 5, correct? So what's he missing then? That he's got? 3 2's. So the shortcut becomes, take the largest power you see on each number. So I see a 2 somewhere in here, and there's 3 of them, so I'm going to take 3 2's. I see a 3, and I'm going to take 2 3's, and I see a 5. And the highest power I see is 1. And then you can just do that. 8 times 9 times 5. 72 times 5, which is 36 times 10, is 360. Or you know. Real quick, can somebody help me? 2 cubed is 8, 3 squared is 9, 8 times 9 is 72 times 5. How do you multiply by 5 again, easily, in your head? Compensation. What's a really cool number to multiply by, besides 1? 10. So if I got 72 times 5, I can borrow a factor of 2 from 72, yes? So 72 times 5 becomes 36 times 2 times 5, 36 times 10, 360. Yes?
Is that how you do that?
Yes. That's compensation. Somebody should write it down. Compensation. So 8 times 9 times 5, 72 times 5 is 36 times 2 times 5 is 36 times 10 is 360.
Yes.
I love you guys. I was writing all that and you couldn't see shit. And you're like, let's just wait. So, I mean, if you guys haven't realized, everything you're learning in this class is a lot of this stuff you can just use in your everyday life. Because we've either forgotten this or you had a teacher that didn't really show it to you this way. What's up? What's up?
So, would we, probably left it with the cross factorizations if you want?
No, not really. Especially if it's like 11 to the 17th or something, you see from, I don't want to see a big ass number there. It's kind of small. You can, if you didn't multiply it out, you'd be fine. Yes? 10?
I mean, yeah.
10?
Can you do 10 and 11? Yeah.
Do it again, sorry?
Can you do 10 and 11?
I guess so. Alright, so. Do you guys remember the rule for 6? To see if something divides by 6? Has to be divisible by 3 and 2. Why is the rule for 8 not, it's got to be divisible by 2 and 4? That is not the rule for 8. Why not? 2 2s is 4. So listen, if I tell you 4 goes into a number, and then I tell you, oh yeah, 2 goes into it also, did I tell you new information? If 4 goes into a number, don't we already know 2 goes into it? I need this to make sense, because this is the idea of relatively prime. 2 goes into 4, so if I know 4 goes into a number, I already know. So if you tell me, oh yeah, 2 goes into it, I'm like, thanks man, I still only know that 4 goes in. But if I tell you 2 goes into a number, and 3 goes into a number, 6 has to go into it. Because if I divide it by 2, 3 still goes in. Okay, maybe. So if they're relatively prime, then I can multiply and say that bigger number goes in also. That's where the rule for 6 comes from. So if it's even, what number goes into it? 2. So I already know 2 is a factor of A. What else is a factor of A from number 10? 7. So 2 and 7 both go in. So does 14 go in? Yes, because 2 and 7 are relatively prime. Yes? Yes, at all with me? Screw you, Jeff. No, so if 7 goes in, I can divide by 7, and something's left. If it's even and I divide by 7, do you all understand it's still going to be even? Give me an even number 7 goes into. 28. What's 28 divided by 7? The answer is even, yes? Of course it is, because if I divide by 7, I'm not taking the factor of 2 away, am I? It's going to still be there. I don't know if you guys are with me. So if I'm told that 7 goes into a number, 2 has to separately, and it's even, 2 has to separately go in, because 7 doesn't take the factor of 2 away when I divide by it. So, to boil everything I said down, if I know 2 numbers go into a number, and those 2 are relatively prime, then their product goes in. So if I know a number is divisible by 11, and I know it's divisible by 7, that means I know it's divisible by 77. Because 7 and 11 are both relatively prime. Okay. Is that okay for that one? Alright, what about 11? How do you use subtraction to do that? Yeah, subtract. You're not going to believe this. Subtract the smaller one from the big one. And I talked about this at length before as to why this makes mathematical sense. GCF means, okay, you see, I really want you guys to get this. This is such a beautiful idea. When I have a list of multiples, 3, 6, 9, 12, and I keep going, every number in that list is divisible by 3. If I take a difference between any of those 2 numbers, the difference is also divisible by 3, yes? Because the distances are all multiples of 3, yes? Okay, so if I subtract, I am maintaining, whatever the answer to this is, has to be in, how do I say this? This gets tricky. Trying to figure out a way to say this that's better than what I got in my brain right now. So like, if I have 6 and 9, I'm trying to figure out their greatest common factor. This is a silly question, yes? Because they're both already in the list of multiples of 3, yes? So 3 goes into both. Now, well, what's the GCF of 6 and 12? Is it 3? 6. The greatest common factor. Because they are in the list of 6, 12, 18, so 6 is the greatest common factor. But notice, what's the difference between these 2? 6. What's the difference between these 2? So if I can subtract down, so if I take 300 away, the answer stays the same. I just have better numbers. How do I keep going with the same idea? Subtract 240, so this becomes 240 and 60. Can you guys, right now, can you tell me what number goes into 60 and 240? 60. You're done. If you can't see it, you keep subtracting. Yes? You need the biggest number that goes into both numbers that are in there. Now, do you guys see that? GCF is 60. 60 goes into 60. Brown shaky. And 60 goes into 240. Look back at the original problem. How far apart are 540 and 300? 240 bar. if I start counting by 60s, 60, 120, 180, 240, you with me? 300, 360, 420, 480, 540, 540, see? Aren't 300 and 540 both in the list of multiples of 60? That's what we're finding. We're like, what is the biggest number that these are both in the list of multiples of? That's why subtraction maintains the answer, because they're still going to be that distance apart. Maybe. Or it's magic. Either way. Okay. Such a cool idea. Like, yeah, Jeff, everything's cool. All right. What else we got? Yes.
Could you, please tell, what you said at the end of number 10 again? It was like, if you know two numbers that are relatively prime go into.
Yes.
Yeah.
If you know two numbers that are relatively prime go into another number, the product of those go into it. So like, real quick, does 3 go into 60? Yes. Does 5 go into 60? Yes. So does 15 go into 60? Yes, because 3 and 5 are relatively prime. What's 60 divided by 15?
Oh, sick.
Totally sick. So you might not automatically see a reason to know that, but to me, I define luck to be the more skills and knowledge you have. Because luck is all about having the right skill and knowledge at the right time. So the more skills and the more knowledge, the more lucky you're going to be. So if you know that and you're in this situation, you're like, holy shit, that'll help me right here. What else you want to focus on? We don't have to only focus on those practice tests, by the way. You can ask questions from homework, the last quiz, whatever.
Can you do 6?
6. Yeah, how do I start this off? Is it in base 7 yet?
No.
So if I write the places of 7, am I going to fill them in with anything? No, they're not, it's not in base 7 yet, so they're going to be empty. So you guys still, a lot of you guys do these backwards. Yes, you go the wrong way. If I'm not in base 7 yet, the base 7 places are empty, which is why it's more complicated, because now I got to figure out what the hell goes in to make it work out in the end. That's why it's division and subtraction. It's a little more complicated. Number 7 is easier. This is already in base 12. So I know what's in each place. Okay. What are the places in base 7? 1, 7, 49, 3, 40, 3, and then 2100 something, blah, 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 is too much, yes? 7 times 300 is 2100, blah, 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 is too much, yes? I don't even care what the number is exactly, because I know it's too much, who cares? Are you all with me? So I've written the places of 7 that I need for this number. So what do you do now? Yeah. So take 854 divided by 343 and see what's the whole number is. How many 343s can help me build 854? 2 of them. Now how much is left? 2 343s is 686. 168. Sounds about right, yes. And then you repeat. You just do it again. How many 49s take care of how much of 168? 3. 3 times 49 is 147. Take it away from 168. You guys see that? It's the same process just over and over. So there's 3 49s, and they take care of 147 of this. And that's 21 left, yes? How many 7s take care of this? 3. How much is left?
0.
So how many 1s do I need?
0.
0. I was like, for a minute, like, what the hell are you saying? It ain't So what is the answer? Yeah, 2,330 base 7. 2330 base 7. Put a little 7 next to it, a little tiny subscript. Just like number 7 is base 12. Any one of these, if you're like, can we do another one like this? Yeah. I can make this shit up all day.
Can you do 7? Just 'cause it's now.
Sure. We'll do 7 and then you got a different question, Lily?
Yeah.
Okay. Guys, what's the difference between number 6 and 7? What's the first step on number 7? Why is it so much better? What are my places? What base are we? 12. How many places do I need? I know ahead of time, right? How many places do I have? How many places are in the number I'm given?
3.
3. So what's the A in? What place is the A in? What is the A? What the shit is A? Good. So what do I have in the ones place? 10. What do I have in the next place? What's the next place? 12. I have 6 of those. And what's the next place? And how many of those do I have? 1. So the difference between these two problems is this wasn't in base 7 yet. These were all blank. This is in base 12. I know exactly what's in each place. And then it's easy. How do I put this number back together? How many 144s do I have? 1 plus, how many 12s? 6. So 1 144 plus 6 12s plus 10 ones. Yes? So when I'm going to us, that kicks ass. Anytime, if I'm going from Egyptian to us, from Roman to us, from base 12 to us, it's easier. It's multiply and add, multiply and add. When I'm going from us, like number 6, from our base to another base, that's a little more sucky. That's a little more work. Yes?
How do you get A in there? Like, if you're doing a problem with things, you get A at the bottom, how would you get to A?
Oh, you would get like 10. It would be like I'm doing a problem like this, and I would get a 10 here. So then I have to put an A there. You want to do a problem like that?
Yes.
Okay. And then I'll get you a little. So let's say I'm trying to convert. Ooh, shit, I gotta make one that works. Give me a moment. Oh, shit.
Oh shit.
Yeah, that'll work. Yeah, okay. So let's convert 304 to base 13. Guys! Guys! Help me! How do I do base 13? What do I put down there? What's base 13? 2 Mitch? Too much. Yeah, 13 times this is 1,300 plus more craps. That's too much, yes? So how many 169s in 304? Let's see if Jeff did this right. Did I do this right? Maybe. There's only 1 in there, yes? I think I did it right. Go me. What's 304 take away the 169? So 135. So how many 13s in 135? 10. Now the biggest mistake I get is somebody then tell, how many places are there? How many places are there? How many places are there? 3. So if somebody tells me the answer is this, how can you very quickly tell this is not right? How many places are there? How many places are there? How many is supposed to be?
3.
Shit. So what's the problem is our base cannot handle shoving a 10 into one place. But base 13 needs to shove a 10 into one place. So of course we replace this with A. If it was 11, that's insane. So the answer would be 1A 5.
What, this part? Yes.
It's because if we had 8 fingers, yes? Can't do that easy. We had 8 fingers. Don't take away the thumb or else we got the wall. 8 fingers. Then we would have had base 8. And then we would have all been freaked out by base 9. That would have been Mr. Base 10 would have been crazy shit. And we're like, oh, we gotta come up with a brand new symbol because the symbol for 9 wouldn't exist. We have to come up with a brand new symbol, then we probably use whatever our alphabet was if we're creative like that. I don't know if you guys work here or not. So base 13 is trippy because it's dimensions up from what we already use. Of course it's gonna be trippy. It has to be trippy. What's the largest single digit in base 13?
12.
So, and what would it look like in base 13? C. So A is 10, B is 11, C is 12. Good. Lily, did I ever get to your question?
Oh, yeah, I was gonna ask you if you could do like an example for doing the region models, like the
Oh.
fraction and multiplying that.
There's one on here like that somewhere in there.
13. At the very bottom.
Oh yeah.
I did it, but I'm not sure if I did.
13A, I want you to give 2 different region models. 13B, you pretty much have to use the rectangular array approach, yes? Do you guys remember the difference between 2 times 3 and 3 times 4? Yeah. So 2 times 3 would be like 2 groups of 3, yes? Alright, so if I want to do 4/5 times 1/3, I have to represent 4/5 this way. Here's 4/5, yes? Almost there. There. Is that 4/5? Yes. Now how do I multiply that by 1/3? So like 2 times 3 would be 2 times 3. So I end up with 6/5, yes? So now I got 4/5 times 1/3. So now across this way I'm gonna break it up into thirds. And I'm only gonna shade one of these in, yes? How many are double shaded?
13.
No, how many are double shaded? 4. Out of how many total?
15.
15. And of course you could check it. 4/15, yes. This is another example of how it's neat to see the physical reality show up. Does that make sense? So you represent the first fraction this way. You represent it like you normally would. Represent it this way. And then whatever the second fraction is, you cut it up into that big parts. And it's all about what is double hatched, what is doubly shaded. 1/3 of 4/5, you take those first 4 brownies, so 4 out of 15 total brownies. So it's kind of like if I took 4/5 of, I make brownies, I take 4/5 of them to school. The other ones I leave at home for me later. And then at school, 1/3 of them are eaten. How many were eaten? 4/15. Okay. So that's like a physical situation. Oh, like this guy.
Yeah.
I don't know. You want to do this guy?
I mean, I just did that one.
What's the only difference between solving inequalities versus solving equations?
When you divide or multiply by negative, you have to switch.
And I've been known to be a complete dork and say, you do that with equations too, just when you flip the equal sign, it looks the same. So, it's cool to put them up. So, and we explain why. just changes the side of the zero you want, so the one that was bigger is now smaller, right? So if you are in the process of solving an inequality and you multiply or divide by a negative, so like what's the first step here to solve for x? Add 5. And then what do I have to do? Did I divide by a negative? Did I divide by negative?
Yep.
Yes, so my sign has to flip. How do you divide or multiply by a negative? Yeah. People will flip it if they just see a negative somewhere. No. You have to divide or multiply by a negative. And then the sign flips. How do you check yourself? Before you practice. Yeah, actually you plug 1 in. No, -5 won't make it work, because the answers are all greater than -5. Can somebody give me a really simple answer that's a big number that's bigger than -5? What do you when you plug a 0 in? Plug a 0 in. You get -5 is less than 10, is that true? I feel pretty good then. I feel my inequality symbol's going the right way. So if you forgot to flip it, plugging a 0 in should make it not true. If the answer was x is less than -5, 0 should make it not work. So when I plug a 0 in and it works, I'm like, oh shit, whoops. I don't know if you guys are with me. How many answers are there to this part C? How many answers are there to part C? Infinite number, good. There's like this way to write it, but there's an infinite number of answers. I pick 0 because 0 is awesome. When you plug 0 in, it just kills the part of the thing you plugged it in for. So you can always check your answer at least on a certain level to make sure your inequality symbol's facing the right way. You can just pick a number that actually meets it, plug it in. You could always choose 0. I don't know if you guys are with me or not. Right now, 0 should make it work. If my inequality symbol was the other way, 0 should make it not work. So you can always plug 0 in to check your answer. Screw you, Jeff. Yes?
When you're done with this one, could you, please show an example of the lattice addition?
Yeah, I'm done with this one. Alright. Lattice addition.
I know.
Is when you've got like, I don't know. Oh, did I put too much? Maybe I did. Oh, shoot. Yeah, I did put too much. I put 1 row too many. I'll be alright. So then 8 plus 5. 8 plus 5. 13. Here, let me do this again because I think I was doing multiplication. So 13, 3 plus 7, 10, 1 plus 4, and then you go diagonal. 3, 1, 6. And you see how that one, this one ended up affecting the second spot. This one ended up affecting the third spot. This naturally leads towards carrying the 1. The lattice method is not like done everywhere, but it is an interesting little, it's kind of a nifty little bridge between models to lead towards carrying the 1. Yeah.
Can you do 26B? I know you said you were done with that.
What's up?
Like the equation with fractions, 26B.
Here's the great thing about equations. You ready?
Ready.
If there's a part of it, now again, I'm pretty sure I said this last time. This is not a life lesson. But if there's a part of an equation you don't like, you could very often kill it, right? Guys, don't do this in real life. One of my students killed somebody. I didn't tell him to. So what part of this equation do you not like? Really? You don't like, okay, yeah, true. We don't like the fractions, correct? Why do the fractions exist? What does this over 3 mean? What is the 3 doing? What operation? Division. So how can I kill it? I have an equation, which means I have 2 sides that will balance each other out. As long as I do the same thing to both sides. It already is divided by 3. How do I kill it? Multiply by 3. If I do the opposite operation, I cancel it. Or the way Jeff says it, I kill it. So if I multiply everybody by 3, what happens? What do I get there? X. 1 times 3 is, that's crazy. What do I get there? 5. I mean, immediately it's magnitudes better. Yes? It's silly better. It's kick-ass. Do you have to kill fractions? No. Do you have to? Do you have? No. You can subtract 1, and then you can multiply by the reciprocal. But I'd rather kill a fraction, sorry. I'm really good at math, but I'd rather kill the fractions. I don't want to work with them unless I have to. Because there are places humans make mistakes. Yes.
Sorry, could you please do, 23?
23. Oh, it's right there. Oh, yeah. We could have done that with these. I still have. Good. All right. So if I'm using a set model, let's draw this out. What do I start with?
Oh, is it just the, like, circles?
Yeah.
Oh, okay, never mind.
So the way I do them is like I start with 5 negatives. Yes. Looks like eyebrows and a very unamused. And then what do I need to do though?
You're taking away.
I'm taking away more negatives than I currently have. So what I have to do?
Add a 0.
Now, if I add a 0, am I able to take away 6 negatives? So I'm left with. So that's 1. Yeah. So let me give you guys the answer key before I forget. I just was like. Wow. More just writing.
Dude, I'm dead. She's so right. That's gonna piss me off. I know. We're just gonna work it for
Just to let you guys know, I am sad. I'm not teaching 126.
Oh, we're set.
I'll miss you guys. The day of the final, it always hits me, and when I'm giving the final out, I stop for a minute and I say, it's been a really great semester. And I almost start to tear up because I'm like, we've been together for 16 weeks almost here. And then some of you guys I'm never gonna see again. And that's trippy. Same thing's gonna happen to you as a teacher. You're gonna have certain students that kind of like reach back to you. But you're gonna have a bunch of students you see and then you never see them again. You're like, what are they doing now? So, even if you, I'll see people out, and then they'll say, Mr. Waller, I'm like, oh. Or I see somebody like, they look familiar, but did they pass my class? Should they say, anyways, it's always a little weird. Filter too, but it's fine. Good luck. So anything else you guys wanna look at on here, or?
Can you look at number 24?
24? Oh, alright, so what's the, two negatives make, when you multiply, three negatives make, because two kill each other, yes, four negatives make, okay, so we can make a shortcut out of this, right? Every odd number of negatives makes, check, every odd number of negatives, two kill each other, two kill each other, two kill each other, you're left with a negative, right? So how many total negatives are in that? I think I did it a little differently on the key, but, no, there's nine negatives.
9 and 5.
And 5, so how many total negatives?
9, 14.
14, so this is how, an even number of negatives, they all kill each other, so the answer is,
Asking what if it's positive or negative, that's, okay.
I don't care what the number is, I just wanna know is it negative or
I don't
positive.
know what was the sign. I don't know.
Gotcha. Does it make more sense now?
Yeah.
Yeah, so if I would've made this an 8th power instead, then the answer would have been negative, because there were 13 negatives, one of them would have stayed alive, while all the other ones fought to the death.
Is there a possibility you teach the other class not this upcoming semester but the following?
The 128?
No, like, will you not, you're not teaching next semester?
Oh, I see what you mean, I'm sorry, I thought you meant the class after 126.
Okay.
I mean, if
128 is this mythical thing that I don't know if it's ever
You
coming
do
back.
what? You should
Sorry.
teach 128.
You should.
I have never taught it, but it sounds really neat to me, we need to bring it back. It's always a question of finances and demand, I think, so. There obviously is some demand.
Because I need it.
But yeah, it depends, it always depends.
Because that's the thing.
Like I said, next semester I'll be one step up, but I'll still have Carrie in front of me.
Tell Carrie,
So-
Carrie, is that thing?
But I can negotiate, we'll see.
How about we all negotiate?
But no,
Listen, buddies. All of us? Yeah.
yeah, that's what, and then it doesn't work, and then you really want his downside.
And then
You
he
can't
gets,
do
and then we
that.
go to class.
That's all. Listen, I was just joking.
We should get you up there.
No, I'm sorry.
One of the greatest judgments that we always.
But, you know, I always tell my students, if my office door is open and I have none of my students in there, you guys are free to stop by, even after you're not my student anymore.
Can we talk about 126 in your office?
That's what I mean, if you have questions.
Perfect, but don't you share? an
Because
office?
Carrie and I are both in there.
And we just don't.
But we're not gonna be in there at the same time. Yeah, that'd be funny. Yeah, you ever help with 126, Jeff?
No, we're gonna ask you. Yeah.
If I'm in there and Carrie's not there, I can help, that's what I'm trying to say. So guys, anybody still have questions? Yes, what's up?
Since you don't post grades on Canvas, where will we see our final? Like,
It's in self-service, but also,
no, like, how do we know what we got on our, like?
the minute you're done with the final, I don't, you could even email me before, and I always find it so funny that a student will email me, and they'll say, I'm so sorry, I know you're not done grading, but, you know, I'm like, I don't give a shit, just email me, and I don't look at the emails until I'm done grading, so I don't care. So, you email me before you take the final, and just say, hey, let me know how I did, thanks man, you know. And then when I get done, I'll go back, answer.
Yay.
So then I can tell you like, what you made in the final, what you made in the class total, blah, 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 blah. Yeah.
So we won't see our paper though.
I mean, you can come back next semester, look at your final if you want.
This one.
It's okay, you're probably already gonna
Look
be in
what
the
you,
office.
look what I did back.
Well, I just wanna, but I'm not.
But
Some of you already did well this semester, you're gonna be okay with that.
You can see it.
You mean all of us?
What's up?
Except Lauren.
Oh, yeah, Lauren's leaving us.
Are you off to a different college?
Wait, what? I know, what?
That's basically right now.
100.
Where are you going?
Yeah, I know, right?
Lauren, where are you going?
Yeah.
Are you going to university? Which one?
What the heck?
How come we're just not looking this bad?
I know, I told you. Exactly.
I actually have no idea how San Diego State's education program is? Is it supposed to be a good one?
People say it's good. I have a couple friends that really like it. I don't know.
I know a few young people.
That checks out.
So congratulations. Is anyone else trying to transfer soon?
Jonathan Lauren, what the heck?
You're transferring soon? Not next semester, but in the fall?
Come on, man. I don't know.
Alright guys, anything else? O'Reilly? Alright. That's enough. So I'll see you guys on Thursday. I'm gonna bring snacks for me to eat you. No, you can have. You can have.
Like the thousands, hundreds, well,
It's actually related to a friend group of mine. It's actually not mathematical.
Oh.
They call ourselves the Lookout
Oh.
for all kinds of reasons.
Okay.
You would swirl people in and swirl people
Well, like, next time you take this class, like, yeah. Because I think, yeah, next semester, and then I just like.
Oh, yeah, I mean, some people like, there's some people that are truly inspired. Yeah, that's based on the Nazi sequence kind of stuff, but.
Oh, I know. You're not going.
Depending on the level of math, they get different